Okay, today's tutorial we're looking at dimensional analysis. Now, dimensional analysis is just going to be a form for problem solving. So typically you're going to be given a known within your problem. I like to set my known over 1 with not only the number but also the unit here. The key to dimensional analysis is looking at your units canceling out. I put it over 1, so when we put our conversion factor next, everything lines up. Now note how I put a multiplication symbol here and not an equal sign. Equal sign would mean cross multiplication. Our multiplication sign means we want to multiply eventually times the top and divide by the bottom. Now the unit that you have on your first one, I'm going to call it unit A. We're going to need our unit A to come down on the bottom and cancel it out. So we're going to have some number with our unit A per some amount of our unit B. So we're going to have our number unit B right here. The great thing about dimensional analysis is that it's a uniform set procedure. You want your unit A to cancel out with your unit A down here, and then whatever unit you're looking for will be that unknown answer. So then we would have some number in unit B. So let's try an example. The biggest thing about dimensional analysis is not to forget your units. So a hen lays 250 eggs in a year. How many dozens does she produce? So we're going to put our known first. So we have 250 eggs. So what do we want on the bottom to cancel out? We're going to need eggs here, and what we want to know is how many dozen. So we're going to put dozen up here. Now, we know that there are 12 eggs in 1 dozen. So we're going to put our 12 with our eggs per 1 dozen. So we're going to multiply across. So we're going to do 250 divided by 1 times 12 is 12. Let's make sure our units cancel out. So we have eggs canceling out with eggs, and we're left with dozen. So let's get our calculator out, and we're going to do 250 divided by 12 and get 20.83 dozens. Now, if we look at the given here, we're going to keep in mind our sig figs. So 250. Is this zero significant? It's to the rightmost, but there is no decimal here, so it is not significant. So we're going to have 2 sig figs in our answer. So we're going to count over 1, 2. Does the 8 round up? So we have approximately 21 dozens from this particular hen. Now let's try another example. If there is 25 students in a class, how many pizzas will the teacher have to order to guarantee each student gets 1 slice? So our given information is that we're going to have our 25 students. We're going to put our known right here with our unit over 1. Now each student is guaranteed 1 slice. How many slices are in a pizza? Since they're only getting 1 slice per student, we could do student per 1 slice. How many slices are in a pizza? 8 slices per 1 pizza pie. And we're going to figure out how many pizzas this teacher needs to order. So our students and student cancels out. Our slice and slice cancels out, and we're left with our pizza pie. So we're going to do 25 times 1 times 1. So we have 25 on the top. 1 times 1 times 8. We're going to have 8 on the bottom. So let's do, in our calculator, 25 divided by 8. So we're going to have 3.125. Now, she wants to guarantee, or he wants to guarantee, that each student gets 1 slice. So we have 3 pies, but we still need 0.125 of a pie. So how many pizzas does this teacher need to order? They have to order 4 pizza pies to accommodate this class. Now we could take this a step further out and say if each pie costs $10, how much would this teacher spend?